Hey guys, welcome to Polar Coordinates. We have our XY axis, but but instead of calling it the origin when we're in polar, the center where the origin is called the pole, and the polar axis is our 0 degree line. If this is my polar axis, which would be the same as my x-axis, and that's my pole, so this is the terminal side of my theta, then we have this line. And now instead of being a unit, so now our terminal side can be any length. So we're not working with a unit circle anymore, okay? And instead of giving x, y coordinates, which we do for rectangular, Cartesian, same, we give polar coordinates, which is r comma theta. These are polar coordinates, where r is the radius. It wouldn't be the radius unless we were on a circle, but it's the length of that terminal side. And theta is, again, just the angle between the polar axis and our terminal side. So for example, on the bottom here, we have 2 comma pi over 4, which means that we're going pi over 4 from our, same as what we would call 0 degrees, we're going pi over 4. And the length now of this line is 2, and we write it as r comma theta. R is 2, and theta is pi over 4. When we go to start plotting points, first we have to have, there's our unit circle. Let's call this a circle of radius 2, radius 3, and given what we're being asked for, that's all I need, okay? And then this same as always, so let's just start with 3 comma 5 pi over 3. Always, I recommend that you start with the angle. So our angle is 5 pi over 3, which is the same as 1 2/3 pi. This lands in quadrant 4. And that angle we'll call 5 pi over 3. And then what we want to do is we want to count out 3 circles because this is our radius. So we would go 1, 2, 3. And this point right here would be 3 comma 5 pi over 3. 2 comma negative pi over 4. Well, negative pi over 4 again is going to be in quadrant 4, where that angle is negative pi over 4. And for this one, we would, since this is our negative pi over 4 line, the red line, what we do is we just count 1, 2 from the pole. Our r comma theta is 2 comma negative pi over 4, and that's where that is. 3, 0, well, that's kind of easy because our angle is 0, degrees are radians, and our radius is 3, so we count out 3 circles, and we stay at 0. So this is 3 comma 0. And then the last one is the hardest one for people to kind of wrap their head around. We're starting with our angle, which is pi over 4. If we put it out here at this point right here is 2 comma pi over 4. How do I get negative 2? Well, the way I get negative 2 is I go exactly in the opposite direction. For example, if this is pi over 4, this would be 5 pi over 4 in quadrant 3, which is pi away from pi over 4. or exactly in the opposite direction. That's what that -2 means. I go here to my pi over 4 line, and instead of going +2, I go 2 in the exact opposite direction. So this point here is -2. This one, if I call it -2, is -2 pi over 4. And that is that point right there. Again, go to your angle first. And then the negative just means you go in the opposite direction. If it's positive, you go in the positive direction. That's for radius. For angle, if it's negative, we go clockwise, and if it's positive, we go counterclockwise. Now it says plot the point P with polar coordinates 3, pi over 6. So let's make a little graph over here. And again, I need 1, 2, 3 circles. And we'll make this point right here pi over 6. Now I have my original point, which is 3, 1, 2, 3, pi over 6. A says, I want r to stay positive. It says find other polar coordinates r, theta of this same point. So if r is greater than 0, it's got to be 3. And now here it's saying that my theta is between 2 pi and 4 pi. So this is obviously between 0 and 2 pi. If I add 2 pi to that, I have pi over 6 plus 2 pi, which is equal to 3, this becomes 12 pi over 6, so 13 pi over 6. That is exactly the same point as I had before, but now r is greater than 0, which it was before. The only thing I did different is I added 2 pi, so now it's 2 pi bigger than the pi over 6. I'm going to do C next, because C is the easier one, because again, 3 is my radius. Now, if I want it between -2 pi and 0, what I can do is I can just subtract 2 pi. If I subtract 2 pi from pi over 6, here we have pi over 6 minus 12 pi over 6, which is the same as -11 pi over 6, which is exactly the same point as 3, pi over 6. All right, now let's do B. R is negative. If R is negative and theta is between 0 and 2 pi, we need it to be the exact same point as that. What I want to do is I want to, again, go exactly opposite. Opposite would mean plus either, if it were in degrees, plus 180 degrees, or plus pi. That gives me the exact opposite side. If I were to go to 7 pi over 6 and put my dot here, then when I come to 7 pi over 6, which is right here, and I go exactly opposite, I would get the exact same point that I started with, 3, pi over 6. Come to 7 pi over 6, and instead of going +3, we go the opposite way, which is -3. Well, this point right here is +3, 7 pi over 6. It says plot each point. So 45 degrees is the same as pi over 4. The really dark circles, I believe, are 5s. And inside there's lighter circles. If I were to plot point A, I'm going to go to my 45 degrees And so that would be point A. I'll do all the positive ones first, and then I'll do the negative ones. So that's negative, negative. I'm going to do D next. So 2 pi over 3. Well, that's right here. And I'm going out 2 from the center. And so we're going to call that D. And F, this is negative pi over 6. We're right here. 3 out would be approximately right here. And that's F. That takes care of all the easy ones. I do believe that that's not going to cause problems. The ones that always cause problems are the negative radian. 135 degrees, that's going to be in quadrant 2, reference angle 45 degrees, which is the same as 135 degrees in this direction but since it's -5, I'm going in the opposite direction. So again, my reference angle is 45 degrees, which puts me at 315 degrees. 360 minus 45. Actually, I'm going to be here and I'm going out 5. That puts me right on that black line, and that would be B. Again, -30 degrees would be the same as negative pi over 6 is -30 degrees. I'm in quadrant 4. In the exact opposite direction is going to be quadrant 2 at from -30, my reference angle is 30. It's going to be 150 degrees, which is the same as 5 pi over 6. I go to here, and that is 3. That's going to be right about here. And that's C. And then E is pi over 3. That's up here, which is the same as 60 degrees. And so if we're going to the exact opposite side, so pi over 3 plus pi, it's going to be 4 pi over 3. That's right here. And then I go 5 in this direction, and this is point E. I've actually plotted every point. Just remember the negative R. If we were going in this direction, positive, then this direction is negative for R.